Okay, so now, yeah, let's see, guys, let's see how we can able to continue with the previous. Yesterday, we got to know about how to write Lambda expressions. And okay, today we are also going to understand. Okay, today we are also going to understand how we can able to work with Lambdas, and then we are also going to understand how to work with stream operations. Okay, how to work with the stream operations. That is also we are going to look at into this workshop session. So I want to open the document. Okay, good to know. So we got already how we can able to write the Lambda expressions. Okay, so these are all different function interfaces, and I told like how we can able to write Lambda expression. Okay, and yesterday I told about how can we use method reference operator. How can we use method reference operator? So these are the things that I have explained in the last class regarding I can say the yesterday's session. So how can we work with method reference operator? We can use method reference operator to refer a static method, or you can use method reference operator to call instance method, and also you can also use a method reference operator to reference a constructor. Okay, to reference a constructor also we can use the method reference operator. Okay, good. In this example, okay, in this given example, I'm adding the method reference operator to refer this static method. So I have a class called example. In that class, I have a static method. And I want to refer this static method in the Lambda expression. So in the previous session, I told what if your Lambda expression has a single statement in the body, and that statement is to refer any static method or any instance method, then you can shortcut that Lambda expression with the help of method reference operator. It makes your Lambda expression very shorter, and it will also improve the readability. That is the advantage of using the double colon, which is called method reference operator. Am I clear? Now we are going to now we are going to discuss, of course, method reference operator that we are going to use in the stream operations also. Of course, we are also going to use a method reference operator in the stream operations. So before I start with the stream operations and what are the stream operations actually, and also while working with the stream operations, we are also going to understand about something called as what is that? Sorry, we are also working with optional class. Okay, so these are the things I'm going to cover in the stream operations part. We are going to first of all understand about stream operations, and while working with the stream operations, we are also going to discuss about once again Lambda expressions, and also we are going to work with optional class in the Java 8 version. So basically from Java 8 version, optional class is important, and writing the Lambda expressions and understanding the Lambda expressions. So that is also another important thing. And other thing is stream operations, which are very, very crucial in application development with Java 8 version. So with all this regard, we have discussed about how to write the Lambda expression, and extensively discussed about what are called functional interfaces and how can we implement those function interfaces with the Lambda expressions. That is what we have discussed in the previous session. And in the I mean, day before yesterday as well as in the yesterday session also. But in this current session today, we are going to actually look at about what is the use of Stream API and how Stream API will help us. Okay, and what is parallel stream and how parallel streams can provide better performance and what is the optional class. So these are the things I'm going to cover in the today's session as well as in the tomorrow session. As you know, this is the workshop that we have started day before yesterday, and it is a 4 days workshop. And out of 4 days, we have completed the 2 days of workshop already, day before yesterday and yesterday. And today and tomorrow, we are going to focus on the stream operations and optional class, and how do we write the better stream operations by creating different applications, different examples. Okay. So I am going to talk about Java 8 stream. I am going to talk about Java 8 stream operations. Good. Good. See, we have to understand about for anything, the first part that we need to learn is what? Why we need to use the stream interface of Java 8. So we are calling it a stream API. It is actually called as stream API. Stream is an interface, okay, from Java 8. Okay. So now we are going to understand what this is stream API. Okay. So okay, sure, you are going to get that. See here, guys. Everybody, my requirement is, okay, my requirement is, first we need to understand difference between collection and stream. Okay. See, consider, okay, I'm just going to talk about that. Consider just a minute. I just want to use my writing pad if possible. Just a minute. I'm trying for that option. Okay. I think it is not allowing me. It is not allowing me to write with my writing pad. Okay, no issues. I will use, don't worry, I will use the other drawing tool so that I can explain. See, guys. Okay, right. So the first thing we need to understand is why actually we are going to use Stream API. Assume that I have a uh, I have an array list object, okay, which is containing some elements of type order, which means I'm telling like this now. What I'm telling, suppose assume that it could be employees or it could be orders, whatever it is. Let's say, for example, I have a list of orders. Okay, I have a list of orders. Let's say, for example, I have list of order. Okay, let's say orders equals to new array list. And you know, orders dot add, and I have added some new order. This each order is containing order ID and the ID of the customer who placed this order, status of the order, total price of this order, and let's say, for example, ordered date, like date purchased. All these details are available. Assume that. Okay, orders dot add of another new order. Like this, I have some order elements. All these elements of type order. Okay, there are many elements are there, many more. Okay, so you guys can understand, I have a list of orders. Okay, I have a list of orders and I have added all the orders, okay, in the list. Let's say it could be some number. It could be some 100 or 200 orders are there and I'm adding all of them into the list. Okay, now my question is, uh, suppose, suppose you want to process these orders. Process means, see, for example, I want to segregate from this list of orders, I want to segregate, let's say, delivered orders. So each order contains a status. Maybe some orders are having status like delivered. Some of them are having status like processed, or some of them are having the status like shipped. Okay, or some of them just having the status called just ordered, processed, shipped, delivered, refunded, cancelled. Okay, these are all the different order status, right? So let's say, for example, from this list of orders, I want to just segregate all the delivered orders. Okay, means from this list, I want to only retrieve all the delivered orders. Okay, I want to retrieve only the delivered orders from this entire list of orders. Could you guys tell me how I can do this? Anybody in chat box, or better you can write your message in chat box, or you can directly speak to me, no problems.
We can apply filters.
You can't apply filters because I'm talking about a list. In list, we don't have filter. I'm talking, I have a list only. Okay, I'm not talking about the stream. I'm only talking about list object. Stream
You use contains method in list.
contains is just for verification. Suppose in the list this element exists or not. How can I confirm this element exists or this element does not exist? That is for searching. Contains method could be used to search for a specific element. But out of, let's say this is a list of 300 orders. Out of them, let's say 120 orders are already delivered. Now I just want to get them into another list. Means I want to add them to the one more list. That is called delivered orders. Suppose that's my requirement. My question is, how can I process that? I mean, how can I process these orders and how can I segregate the delivered orders into one more list?
A flat
we
map
need
or
to
map will use.
In the lab, by looping.
shit.
In the lab,
No
in the
map.
lambda
Do you have any
expression,
map?
we
You don't have any map now. You don't have any map. You don't have any flat map on list. I'm
by
talking
looping.
about only streams.
In
I will
the
explain. I know. I'm not talking about stream. I'm only talking about collection.
Adding method.
sir, in the lambda expression, we can return only orders dot deliver equals to order dot status equals to deliver.
Okay. Means how do you do that? I mean, basically, okay. Lambda stream means okay. You guys have already good idea on that. Okay, I expect. Okay, then my job is very easy. Yeah, good.
Sir, by looping.
Okay, good. Actually, there is, see, there is what I'm expecting the response from you is, if at all you want to first of all sequentially access one by one element and check whether it is a delivered order or whether it is not a delivered order, first you should start iterator or a for each method or for each loop. Without that, how can you, you know, check whether it is a delivered or whether it is not a delivered order? So the first thing what you have to do is, my requirement is what? This is my list now. Requirement is what? requirement. Okay, requirement. My requirement is segregate the delivered orders into another list. That's a requirement. I have a list of orders. Segregate the delivered orders into another list. Then tell me what is the solution.
First we need to iterate till all the
Ah,
list, and then we need to add a condition.
you are right.
If
Hmm.
we can
Okay,
add
now
it to another list.
you got. You're right. You're right. Now, what is the point here? First, you guys need to use iterator.
List iterator.
Okay, use iterator, list iterator for each. Okay, any iterator means let's say for list iterator, anything. So use iterator or for each loop or for each method. Anyone, use them, use iterator. Then while iterating, you can apply the condition. Apply the condition. If met means if the condition is satisfied, like what the condition is, this order is delivered order, what's the status? Take one by one order from the list, if find the status of it, and if the status is delivered, if the condition is met, then add it to another list. Right? This is a solution. This is a solution for the requirement currently. Next. Now let's say, for example, I have this list now. My list is containing around, let's say, could be 10 million orders. It's not 200, 300 or a 50K. Okay, it is, let's say 10 million orders are there in the list now, 10 million. My next question is, what if the list has 10 million orders? What if the list has 10 million orders? That's my next question. Then
It increases file complexity.
okay, if the list has a 10 million orders, then what should I do? Okay, let's say for example, my list has 10 to the power of 18 orders, 10 after 18 zeros, 10 after 18 zeros. What if the list has 10 million orders? Okay, now what if the list has, okay, what if the list has 10 to the power of 18 orders? Okay, so this is where the concept that you need to understand. Okay, so when the list has, means when any collection has some limited amount of or limited number of elements, could be 5K, 10K, 50K. Okay, it's okay. But what if the list has, if the collection object has many elements, then processing will take more time. Right? Because you need to use iterator or you need to use a for each loop. then it is going to take more time for iterations. So if you use even a supercomputer also with having a high speed clock cycle, if the list has 10 to the power of 18 orders, okay, approximately it may take 1 year time. Okay, to process the list of having 10 to the power of 18 orders, a somewhat big computer, a good computer also will take, with more clock speed, approximately will take 1 year. Okay, cool. So we are understanding about why actually we are going for streams. So see, collection is good for storing the elements. We can store large amount of elements. We can store large number of elements. We can store in the collection object. But when it comes to processing, using an iterator or using a for each loop or for each method, processing will get delayed if in case the list has a large number of elements. That's why what happened in Java 8, there is a separation given from Java 8 version. Use two different objects. In that, use collection object only for storing the elements. It could be any number of elements. In a collection, we can store any number of elements. Right? Any number of elements we can store in a collection object. So we can store. It could be in millions. Okay. But when it comes to processing, instead of using collection to process it, create a stream for the collection so that you can improve the performance. Okay. For processing the elements of the collection. That's why the two different objects, one is collection and other one is stream, and both are used for two different purposes, where collection is used to store the elements and stream is to process the elements. So that's where there is a difference between a collection and a stream. So how stream can process this much big number of elements? Like, for example, if I have 10 million orders. So in streams, there is a concept available called parallel streams. So it will run the same operation on multiple cores of the CPU. Means it is going to utilize the complete power of the CPU, and it is going to result in a short time without any delay. That's how the streams are going to provide better performance for processing the elements in a collection rather than using an iterator or a for each loop kind of thing for processing the elements. That is where first we need to understand about why actually we are going for stream operations or stream API. That's the first thing. So the solution is, okay, what's the solution here? The solution is use a stream object for processing. Okay, because iterator or for each, any for each or for each loop, anything, iterator or for each loop or for each method will take more time to do processing. Okay, that is where we need to use a stream object. So basically conclusion is what? What is a conclusion? the conclusion is what's the conclusion? Use collection and stream objects are used for two different purposes. Collection and stream objects are used in Java for two different purposes. Okay, two different purposes. Collection object could be used for storing the elements or large number of elements. It could be small or large. And stream object could be used for processing the elements.
Sir, I have one question.
Okay, that's how it's, yeah,
Hello?
you can make it.
So, yeah. So before the streams, right, before Java, right, so how they used to process, if there are 10 to the power of 18 orders are there, then how they used to process that?
That is what it is get delayed. Okay.
Next we
Suppose
can.
I'm taking 10 to the power of 18. As of now, there was no requirement in any e-commerce application of having 10 to the power of 18. Let us say, for example, if there are 10 to the power of 18, then what will be the solution?
So we can
Okay.
use threads.
So, of course, you have to manually create the threads. See, for example, I have a file. For example, I have a file which has 10 lines and I have to write a Java program and it should find out totally how many words are there in the file. 100 lines are there in my file. I want to count the number of words in the file. Okay, if my file contains just 100 lines, I no need to make use of any threads manually. Just within a single thread, let's say like a main thread, I can able to count how many words are there, right? But if the same file is containing, let us say 1 million lines, okay, then we are going to create multiple threads.
Yeah, we can do the partition, and each partition we can apply the threads.
Yes, each partition
We can apply
is one
the-
thread in one thread.
Yes.
We are going to process each partition one thread. Let's say, for example, line 1 to line 10,000, thread 1 will process it. Next, from 10,001 to maybe 40,000 or 20,000, another one will process it like that. So
Yes.
we are going to manually partition that file, and then we are going to use multiple threads to process it. That's how we are going to do. Okay. And once after the threads are completed, and we are responsible to join the results. So partition should be done manually, and also you also need to join the results, and then finally you should display the final outcome.
Okay.
Right? That is what manually we did. But in streams, we don't do like that. Okay. Stream will do all these things internally. Stream will internally take care of dividing into partitions, and after executing the partitions on different CPU cores, then collecting the results and aggregating like a single result and providing the result to the application. That is all taken care by the stream operations. So that's how the streams are having. It is now reducing the burden on the programmer of manually creating the threads and managing the threads. Okay, that's how the streams are going to perform better performance while processing large amounts of data.
So if we are going for processing, that time in threads only we can add the collection object, right?
At the time of doing, I didn't get you
We can
exactly
add
what I want to.
We can add to that collection, right? Same collection.
To which collection?
For example, if you are going to search some word in 10 to the power of 8 million words, each partition we are applying the threads.
Okay.
Where if we are matching with that word, we can add to that collection. Only one collection we can apply for.
Okay. I mean, see, for example, if the same collection object, if in case I'm sharing with multiple threads, again, I also need to take care of thread safety.
But we are applying object lock for that.
I mean, if you apply object lock, that is called synchronization, right?
Yes.
So if you add synchronization, then again, the performance of your application gets decreased. You have to
Yes.
compromise on the performance of your application,
No.
right? Good. Okay. So basically my intention is what now? Just to give an introduction like how you can differentiate a stream and collection. That's what our requirement. So you should look at both the things are required. I'm not saying that now from Java 8 we have stream, so there is no need of using any collection object because it will take longer time when there are large number of elements are there. Then processing will take more time. That's why don't use collection. Instead of collection, use directly stream. So stream is basically not for storing the elements. Stream you can use only to process the elements, but not to store the elements. But whereas if you take a collection, you store the elements. So for a stream, the input will come from collection. So stream is going to perform an operation by taking the elements from collection. Stream is nothing but basically it's a flow of elements from a source. The source is the collection. And the stream operations will be applied on the flow. So I can, you can visualize, otherwise I'll give the diagram so that you guys can understand it. See, okay, so operations names I am writing something, but you will understand that, don't worry. Let's say, for example, this is one collection. Could be some array list or something. It is one collection object. Okay, I'll use the collection object in this way. Okay, this is one collection object. And this collection object has elements like this. This collection has elements like this, like I could say, I'm taking only 5 right now. Okay, I could say, okay, right. So what I'm trying to say now, I could say something like this now. So I just want to draw the diagram so that you can visualize it easily, right? So that's why I'm trying to draw the diagram here. Okay, let us add one more line so that there are some elements here. Let us say I take only 5 elements, E1, E2, E3, E4, E5. This is my collection object. This is a collection object. It could be any collection you visualize, maybe set a list, whatever you want. Let's say it is E1 and let's say it is E2. I can say E3, then E4, E5. So you can see that E1, E2, E3, E4, E5, this is my collection, right? So now what I'm saying now, stream means it's a flow of data from the source. The source is a collection. Of course, the source could be collection or even a source could be array, because a stream can be created for the elements of an array by using arrays class. Arrays class contains stream method, arrays.stream. So mostly collection will be the source of the data for the stream. Now this is the stream. this is a stream, and okay, let's say the elements are flowing from the collection into the stream. Okay, let me add the elements like this. I can say the elements are E1, E2, E3, E4, E5, something like this. So this is going to be the flow. This is the stream. Okay, the elements are flowing from collection into the stream. And the stream is now going to perform operations. Let's say, for example, it is performing an operation which is like, let's say, it is going to perform a filtering operation. Let's say filter. Let's say it is going to apply some operation which is called filter. Okay, it's going to apply some operation which is called filter. Okay, it's going to apply some operation which is called filter. Let's say, for example. Okay, right. No problem. I will enlarge this box. Okay, it is going to perform some filtration. And when the filtration is applied, let us say, for example, the elements generated from filtration will be, let us say, for example, the elements which are satisfying the filtration, that is just, let us say, E1, E2, E3. So after filtration, the elements are going to be E1, let's say E4, E5. These are the satisfied conditions. These are the elements which are satisfying the given condition. Let's say E1, E4, E5. So actually these are the stream of elements, but after applying the filter condition, filtering them, then only E1, E4, E5 have passed this filter. Okay. And there are many more operations we can write. For example, I'm talking E1, E4, E5. If I add one more filter, again from that, there is only E5 or E4, E5 will be passed out. Or if I apply any other operation, let us say, for example, I have applied an operation like a count how many are filtered. Let's say count. It is another operation. Now, finally, this count is going to, let's say, produce me the response like 3. This is my end result. Okay. So, which means for any stream, the source of the data will be from collection, or the source of the data could be the collection object, or it could be an array object also. So this is one operation I've explained actually, but on the stream, there are multiple operations are available. It could be the filter, it could be the map, it could be the reduce. So later I will tell you about sorting and all this. Okay, limits, skip, many operations are available. They're all called intermediate operations. I'll tell you that. What is intermediate operation? What is terminal operation? So in this, if you observe, on stream, this is the operation that we have applied. And stream could process the, the operation in a better way and fast when compared to using iterator or for each loop manually. And this is a terminal operation which is providing the result. So the filter operation is called intermediate operation, and this operation, last one, is count. This is called terminal operation. So basically, on a stream, there are two types of operations are defined. One is called intermediate operation and other one is called terminal operation. That is called to perform any processing. Then the stream operations are consisting, two types of operations. Okay, that is called intermediate operations and terminal operations. See, if you look at the filter operation, it is taking a stream as an input. We'll apply the filter operation on the stream of elements and creating another stream. Let's say this is one more stream, but this stream is containing just only, let's say 3 elements. This is a stream which is containing 3 elements only. So this filter is transforming this source stream into this destination stream, which is nothing but it's producing another stream, right? So that's why it is called intermediate operation. So intermediate operation means it is an operation which produces another stream, which is nothing but it is going to transform a stream to another stream. And this is called terminal operation because it is providing us the final outcome. Otherwise, we can say the result, it's producing the result. That's why this is called terminal operation. Like that, you have two types of operations available. One is intermediate operation and second one is called terminal operation on streams, right? So we have two types of operations. First, let me, this diagram I can't add into the notepad, but we can understand the diagram, but I will write the statements. This diagram I can't copy. If anybody want, you can draw it, or if you want to remember it, you can remember it. But other statements I can copy into our document, and at the end of the session, I will share the document, okay? So that is what we are discussing about stream. Next, I just want to copy all these things. Okay. And finally, I just want to copy this one as well, the conclusion. And this diagram, you people can draw or you people can remember it. It's up to you. Okay, right. So if you talk about stream operations, there are two types. Okay, one is going to be the intermediate operation and other one is going to be the terminal operation. One is intermediate operation and second one is a terminal operation. Now, what is intermediate operation and what is terminal operation? As just now I told you, intermediate operations will transform one stream to another stream. Right. Intermediate operations will transform a stream into another stream. So terminal operation will produce a result. Now, intermediate operations will transform a stream to another stream, whereas terminal operations will produce a result. Okay, that's how there are two kinds of operations and there are different methods are there. We are going to see like filter is an intermediate operation, count is a terminal operation. Okay, And we have other operations like map, flat map, limit, skip, sorted. Many operations are there. So stream API is actually, the problem with the stream API is it is huge. Many methods are there. Many operations are defined in stream interface. So that is the problem with the stream. That's a drawback of the stream actually. Okay, there are many operations are there, and we have to remember at least some of the operations which helps us in our day-to-day tasks. So that's okay. But you could understand that there are two kinds of operations are there: intermediate operation, terminal operation. Now, first, how can I create a stream? We can call stream method. Suppose I want to create a stream. Suppose I want to create a stream object. So how can I able to create a stream object? So if I want to create a stream object, I can able to call a method called stream method. So stream method could be used for creating a stream object. Right? Stream method could be used for creating a stream object. So how, I'll tell you, how can I able to create a stream object? For example, I have a list. Okay. And I want to create a stream object on the list. Let's say, for example, I have a list of orders. As I said just now, I can write something like this: stream of order. Let's say stream equals to what? What's the method I can call? Orders.stream. That's how we can able to create a stream object. Okay, so stream of order, stream equal to orders.stream. For example, stream is a method which can create a stream object. This is called the way how you can create a stream object. Now, suppose you have an array, then you can create like this. Now, for example, I have an array of, it could be anything. For example, I have an array of double values. Okay, that array is containing some values of type double. Then stream of double. Let's say stream equal to arrays dot stream of your array variable. That array variable name, I'm just assuming like ARR is my array variable. And so I can able to create a stream object like this. So there are different approaches available. I mean, how we can able to create a stream object. One is, if you have a collection, then you can call stream method. If you have an array, then you can call arrays.stream method, so that you can able to create a stream for an array or for a collection, so that you can start processing the elements of the stream. Okay. So based on this, now our intention is what actually we would like to know about how we can able to perform the different stream operations. That's what our requirement. So we will see some coding, so that whatever that we discussed yesterday regarding Lambda, whatever the method reference operator we have discussed, and whatever the functional interface concept we have discussed. So all these things I'm going to cover as part of this examples next, further examples. Okay. See, parallel stream we'll discuss next, but first we'll start with only stream. Okay. Then I'll talk about how parallel stream will work and what happens with that. Okay, good. So I'm going to, I'm just going to work with an example. The source code is important now. I mean, at least some source code we want to write. So for that, let us start with the IDE. And first I'm going to create, I'm just creating one order class. Okay, you can see order class. I'm just going to create one order class. And I'm also going to create one enum just to tell you like how enum can be created so that you can explore more on that enum.
Which data structure is using streams?
Sir, I
The
have a
streams
small
are
doubt.
following data structures.
I'm not actually getting you. You're asking for something, but I'm not receiving your voice actually. I mean, I'm not clear about what you're trying to ask me. You can also type in chat box if possible, please type in chat. Okay.
Sir, I have a small doubt. We are using arrays into streams. We are injecting now. So instead of that, can we use int stream?
You have already different types of streams also. Stream is the interface and it has child interfaces like int stream, double stream. Okay.
Okay, sir. Thank you.
So you can use, okay, why not? The int stream is a child interface of stream. Okay. Good.
Okay,
Good.
sir. Thank you.
Good to know. Good to know.
Hello, sir. Sir, for example, we have to collect the user input from some of the integers. For example, 10, 20, 30, etc. Sir, how to use the streams with a runtime, sir?
See, you have a stream for raw values also. Stream.off method is there. I'm not, using, the all possible ways of creating a stream. For example, if you have any raw data like that, then you can create a stream like this. Stream.off is a method. For example, stream of integer for your requirement. You can create a stream like this. There is a static factory method of, and you pass your values 20, 30, 40, whatever the data you have collected, you can pass here.
Yeah, sir. Without hard coding, only I ask runtime.
Okay, you can take runtime in the sense what, where are you storing them? Okay, at runtime only you are accepting, I agree. But my question is,
okay,
after accepting those values, where are you storing them? In a variable like ABCD?
No, sir.
If you are storing them in ABCD, type ABCDE, that's it.
Okay, sir. Got it. Okay, sir.
Yeah.
Thank you.
Yeah. So, okay, guys. See, let me create first some sample code. Let's say, for example,
Streams are using any data.
that is multi-threading. Sir, streams will internally use fork and join framework of Java, FORK and JOIN. Okay. Everybody understand? Streams will internally use fork and join, FORK. And again, don't ask me about explain about that. I will not. Again, that is internally a big story, but I can tell you simply a statement. What is the statement? Streams internal use fork and join framework, FORK and JOIN. Okay. So I'm just going to create one. First, let's create a package. Let's say I want to create a package, and my package is like could be something com.ashok IT .model. Okay, and let's create one class here. Okay, I want to create one class. Let's say my class is order, right? So I want to create a new order class. Okay. So when I'm creating this order, I also want to create one enum. It is not class, I'm creating an enum. And again, please refer enum after the session if you are unaware of it. I'm just creating one enum and I want to name it as order status. Enum is a set of constants, right? I want to define a predefined set of constants, and I would like to assign one of the constants as a value to the variable. Then first of all, I should create one enum. Then I should declare the variable of type enum. Whenever you wanted to store one of the constants as a value to any variable, then you have to create first an enum. Then you should declare a variable of type enum so that that variable can store one of the constants. It will allow only one of the constants as a value. Okay, that's what about enum type. So I'm using one enum. Let's say, for example, my enum is order status. Okay, so I just want to, okay, just I want to write. See something like, I got a question. What can we write? Functional interface inside function interface? No, answer is no. Okay, good. You can't write, sir. You can't write function interface inside function interface. Okay, nested function interfaces we can't write. Okay, let me add the constants. Let's say ordered. I also want to provide each constant can have some value, which is also called description. Let's say ordered. Or if you want to give any number like 1, 2, 3, 4, 5, that is also good. 1 means ordered, 2 means let's say processed, 3 means description, 3 means shipped. Let's say 4 means delivered, 5 means refunded, 6 means cancelled. If you want to do like that, that is also good. Whatever you write along with the constant, we call it as a description. And to store the description of each constant, we need to create a field actually. We are going to create a field of type string because we are writing the description in string, right? We can add integer description for the constant, or we can add a string description for the constant, and you will understand all these things next. Let's say ordered, let's say processed, let's say shipped. Okay, let's say for example, okay, delivered. Let's say for example, refunded. And let's say cancel. I'm keeping a semicolon after the last constant. It's optional, but I'm writing it. Then I'm creating one field. Let's say private string value. And I'm defining a constructor. I can define a constructor of type private, or I can define a constructor of type default, but I can't define public constructor in a enum. So it will give you a compile time error if you write any public constructor. Public constructors are not allowed in enum. Only a private or a default constructor is okay. It is only allowed. This constructor I'm just creating to assign the description of each constant to this field. And suppose if you want to get the description of each field, each constant. So this field is created to store the description of each constant. First constant is ordered. Its description is ordered. And to store the description of this constant, this is the field. And to assign this description to this field, we should define a constructor. That's why until I create the constructor, it has given me error symbols. But after defining the constructor, all the errors got automatically removed. Next. I want to define one public method. See, constructor you should not make public, but you can create a public methods. That's only constructor should be either private or default, but method you can define public. Let's say get value is a method I'm creating, and this should return the value. Okay, this is one enum I have created, and the name I took for the enum is order status. That's the name. Order status is a name, right? Good. Now let's go back to order. Let's say I will take, long ID. I don't want to take many fields because then I should write many parameters while creating the object. That's why ID means order ID. And one more ID, that is customer ID. I mean, who is a customer for this order? That customer ID. I will take order status. I can say status or order status, anything. Now this is enum type. Order status is an enum. And this is a variable of type enum. Next, many things you can take, dates and all. I do not want to write all those things. Simply I will write, to make it not too complicated, I just want to write double total price or total amount. Okay, let's define the constructor, setter, getter. Okay, those kind of things. We are going to define constructor using fields. So then we are going to define getters and setters. Then we are going to define toString method. We are overriding it. And I'm good with this. It's enough. Okay. So just these are my fields in the order class, ID, customer ID, and order status, total amount. Okay. Now, I want to create one more package called com. Okay, .ashok IT .service. That's a package. I want to create one more package. The package name is com.ashok IT .service. And here I want to create one new class that is, let's say the class name is order service. Okay, some class. And here, I would like to define a public static method which returns a list of order. It's a list, and let's say get orders is a method. Okay, so I just want to first create a list of order. Let's say orders is variable equals to arrays dot, as list method is available to easily create the list instead of calling add like that. It will by default create array list object. So arrays dot add list, as list of, I can pass the elements. So let's say, okay, let's say a new order, first order ID 101, customer ID, let's say 20011, that's a customer ID. 20011, that's a customer ID. Okay, order ID is 101, customer ID 20011, and order status, let's say I'm passing like this, order status dot, let's say processed. That's the enum, right? And order total amount, let's say, is 5,799 rupees. Okay. So, the constructor, you can see the first parameter while constructing the object, I should pass ID. The second parameter is customer ID. Third parameter is order status. Fourth value is total amount. So I did like this. Now, let me copy to create some orders with processed, some order with delivered. Okay, let us add the order ID is 102, customer ID 20022. That's a customer ID, and the order status is refunded. It's a refunded order, and the amount refunded is like 5,909 rupees. Let us make the data ready so that we can perform some good stream operations on this data. Again, this is also the order by the same customer with 20011, and this is already delivered to the customer. And this order price is 1799 rupees only. This is another customer 20033, a new customer, and the status of this is also delivered. Okay, let's say for example, this order is rupees of 499 only. And this is again 20011 only, the same customer ID. And but this order, this guy has cancelled it, and he has actually the cancelled order price was 899 rupees. Okay, now it is different. Let's say for example 20022, and just now he ordered and it is not yet shipped or anything, just ordered, and the order price is like 3,799. Last record, it's again 20011 only, and this order is shipped. Okay, say for example, the order amount is let's 1,811 rupees. Okay, some data I have prepared. Then my as list is completed, so I can say return orders. This is my a static method I've created to return the list of orders. Now my requirement is I want to create a method here, the service method I want to create now. My service method, what it has to do is it has to filter and it has to display all the delivered orders. Okay, I have some orders here, but only delivered orders I want to print. It should show me the delivered orders, not all orders, only delivered orders. So public void show delivered orders. Okay, now let's see how we can do it with the stream. Okay, good. So first call the static method. The method name is getOrders, which returns a list it's going to return me a list object, right? When I call the method, this method is ready to provide me a list. So first, I'll call the method to get the list. Right? I got this. Now I want to start stream to perform the operation. What operation I want to perform? Filtration. And you have to understand here. Basically, filter. Just a minute. Here only I'll explain. Okay, look at this. Actually, we have something called filter. You guys can understand. We have something called filter method, which is from streams. Okay, filter method is available. Filter method is available. But the parameter it takes is predicate object. Predicate is a functional interface. Predicate is one functional interface. And if you have a method with any functional parameter, functional type parameter, then you can provide Lambda expression. Like, for each method. Okay. So predicate is a functional interface. And anybody know what is the abstract method of predicate and how many input arguments are there for that method and what is the return type of the method? Because if you don't know them, then you cannot start writing the Lambda expression, right? You can write the Lambda expression only with the help of the abstract method. So that's why I'm asking the question. So, of course, we know that there is only one abstract method, that's for sure. Because it's a function interface which has only one abstract method. Right? You got my point, right? Very good. So the question is now, what is abstract method and how many input parameters or input arguments are there in that, and what is the return type of the method? That's what my question. That's what my question is. Any idea on that? Okay. So basically, predicate is one function interface, right? So it has only one abstract method. Its name is test. So if you want to write any Lambda expression, yesterday I told, even day before yesterday also I've given very clearly, if at all you want to start writing any Lambda expression, first of all, we must know who is the abstract method in that interface. Next, we also need to first check how many input arguments it has. Next, what is the return type of that method? Based on that, we should construct Lambda. We should write a Lambda expression on that basis, on the basis of that one only, right? Yes. So there is only one abstract method available, that is test method, which has a parameter of some type T and returns Boolean. So predicate has a single abstract method like this, Boolean return type, test is method with the parameter T. Okay. So what we are going to do now, we are going to call filter method. But filter method accepts predicate object. So, if any method has a parameter of type function interface, we can provide Lambda expression to that method. To write the Lambda expression, you should start parameters. to start the parameters, you should know first of all how many input arguments are there for the abstract method. And then you should understand whether the body of the lambda expression should return any value or should not return any value. So how can you know that? Based on the return type. So here the return type is what? Boolean. So which means the body of the lambda expression should return Boolean value. Now you should write a lambda expression with one input parameter, and the body of the lambda expression should return Boolean value. Okay. So writing the lambda expression will always depend on the abstract method in the interface. What is abstract method in the interface? Then based on that, you guys need to construct the lambda expression. Okay. So I'm here. Now, my requirement is what? I want to show only delivered orders. Okay. Let us complete this operation for today. So how can I show only the delivered orders? I can write like this. What I can write? First, create a stream. Okay, I can write in one line, but to understand, I'm just splitting this into multiple lines. Now, this statement will create a stream object. Then I told just now there is an operation available called filter. But to the filter, I should pass a predicate object. We know predicate is a functional interface. And predicate has one abstract method with that method has a single parameter input argument and returns Boolean. So my lambda expression I should construct which should match with the signature of the abstract method. Means what? My lambda expression should return Boolean value and it should take only one parameter. And you write the logic whatever you want. Okay. So let me write one parameter, right? One parameter is order, arrow token. Okay, arrow token. And I should write delivered orders only I want to display. Show only delivered orders, right? So for that, I should write something like this. What? Order dot get order status dot get value. Get value method is there in my enum. I have shown you the get value method in my enum. I have created get value method. And get order status returns order status object, which is a enum type. Okay. So if that order status constant value equals delivered, okay. What is the point here? Again, try to understand this. Okay. One parameter. How do you know that one parameter I should start for this lambda? See the input arguments. Okay, for the abstract method of the predicate. Next, how do you know returns Boolean or should not return value or should return integer value? That all depends on return type. So, equals method can return Boolean value either true or false. First, what this statement will do, it is going to first get the order status, the enum variable. And on that enum variable, we are calling get value method, which returns the value of that enum constant. And if it is equals to delivered or equals ignore case of delivered, whatever you want, then call for each. And in the last class, day before yesterday, we discussed for each multiple times. For each will accept consumer object. Okay. Filter represents predicate represents conditions. Consumer represents actions. So I mean, consumer has only one abstract method called accept. It has return type void. It has a single input argument. Okay. So what I do? First, create a stream, then apply the filter. So this filter will convert this stream to another stream, then display that stream elements by calling for each. We can display the elements of a stream by calling for each. Let's say order arrow token system dot out dot println of order. But I told in the last class, if you look at this lambda expression has a single statement in the body with a single parameter and a single statement. And that statement is referencing the method, instance method called println. I told when to use a method reference operator, you have lambda and it has a single statement in the body, it has a single parameter, and that lambda is referring any static method or any instance method or any constructor. Then you can use method reference operator so that you can able to shortcut it. So how can I able to shortcut this lambda expression? I can shortcut the lambda expression by writing system dot out double colon println. So hope tomorrow we'll see more operations, but today I'm giving simple operations.
Sir, I have a question here. Can I ask?
Why not, sir? Yes, you can.
Yeah, so, but in real time, we should not use system.out.println, right, sir? In this line, what we need to write?
No. Actually, this is only to display our output.
Okay.
But in the real time, we are not going to display the output like this, okay?
Yeah.
All the delivered orders, you will collect them into another stream.
Okay.
You are getting another stream, right? You can collect into one more list and return the list. Then your return type is not void. Here also you are going to return type as list.
Okay.
Then it is going to return list of delivered orders. This method will return.
Fine. Fine, sir.
Okay.
Thank you, sir.
Okay. This is only just to display in our session to know the output. Okay. Now, so just today I have created only one operation. Let us see the output of this operation. I'll just create one main in other package like com.ashokit.main or test anything. And this test package contains a main method. Okay, now just create an object of this order service here. Order service. Order service equal to new order service. Then what can I write? Order service dot show delivered orders. That's the method I want to call. Okay, so here two things to understand here. There is a filter and there is a for each. So filter method accepts predicate object, an object of type predicate. Okay, predicate of T, predicate. It is a function interface. Next, for each method will accept consumer object. Something. Okay, so you should know which method is accepting what type of object. And if it is a function interface, then you can pass lambda expression. How do you know how to write lambda expression? That all depends on the abstract method of the interface. Go to the interface and see the abstract method and see how many input arguments are there. Then what is the return type? Based on that, you create a lambda expression. That's how you can do that. Now, let me run the code for today. I'm going to execute this code. I'll go to this main class. I'll execute this code. Now we can see that I have actually multiple 7 orders are there, but it is only showing me delivered orders. And the order IDs are 103 and 104. And the first one, the customer is 20011. And for the other delivered order, it is 20033. So hope I'm clear for today. So this code, did you guys understood the code what I have written here for today? So there are multiple other stream operations are there. We will use this as a base, these orders as a base, and we will see different stream operations on this. We'll see like counting how many orders are placed by the same customer. Okay. Or we want to count how many orders are shipped now. And, we can group by the status, means like how many orders are shipped, how many orders are refunded, how many orders are delivered. We can apply grouping concept. So these kind of some typical operations, not the very simple and regular operations, some typical operations we will continue and we will discuss in the tomorrow session. Okay, so that we can wind up this workshop by tomorrow session. Okay, that's it for today from my end, and I will share this in the Google Classroom link that you have already joined, and you can see the code. Sorry. Okay. So yeah, just 1 minute. So this code and that document will be shared in the Google Classroom link in which you guys have already joined it. So from there you can access it. And tomorrow we will continue to discuss more stream operations, some different stream operations, so that we can enhance your existing skill. If you have no idea earlier, then you can able to, grasp and gain something from it. Okay. So if you have any other queries, you guys can in, or if you have no queries, you can simply log off the session and you can join tomorrow. Same time, 6, 5, 6. The link started 6 or 6 5 in between. Same time.
Sir, for enum, like we mainly use for context only or any other purpose?
Enums are only, see, when there is a requirement of creating a variable to store only one of the available constants as a value, not the any other value. So then you should create a enum for that. Okay. In my example, order status are fixed. Order status cannot be A, B, C, D, X, Y, Z, or M and Y. I can't place some arbitrary string value. It should be one of the available constants. So when you want to create a variable to store a fixed set of constants into the variable, I mean one of the available constants. So then you have to create first enum for that. Like for gender, you can create male, female, other. You can't enter anything other than male, female, or other, right? So then you have to create a enum for that so that you can get type safety.
Okay.
Yeah.
Sir, have you taught previously in Satya Technologies?
I did that. I did that.
Yeah, I learned Spring
early.
from you, sir, in 2015.
Oh, 15. At that time, I taught in that only. Yeah.
Yeah. Thank you, sir. Nice meeting. Hi.
Hi.
Sir, you mean in drop-down list we are using like in front end? Enums are
I didn't get you, sir. Just a minute. Enums are drop down. Sorry.
Sir, in enums used in a drop-down list, right? From front end.
I mean, see, no need of using enum for
For
a drop
example,
down listed. I don't suggest for drop down list as enum, because for drop down list it is better to use map object,
okay.
because drop down list contains key value, na.
Yes.
What will be
For
passing, sir,
example,
when you send
statement.
the request? Okay, good. Sir, key will be passed, sir. Key will be passed, sir, when you send the request in the drop down.
Which one?
Suppose if you are storing like a map,